What's up guys, Shawnthebro here, and today we're going to be going over how we can improve our zooming in and aim down sights mechanics in our third person tutorial and action RPG tutorial series. So for this specifically, we're going to be able to zoom in. It's going to be a nice smooth zoom, and we're still going to be able to do pretty much everything that we've been able to in the other parts of the series. Doing certain actions, such as sprinting, will cancel the zoom. On that note, sprinting and then zooming will also cancel the sprint. So we will have a little bit of movement states going on here because of that. However, the main thing is that we're going to have a fully functional little zoom in or aim down sights operation here. And this is not really aim down sights, of course, but from the player's perspective, if you have a projectile, and it could be a bow, it could be a gun, this would be when they're aiming down sights, when they're looking through something, and this would be like a fine aim mechanic. So, with that in mind, I just want to say that this was something we covered a while ago in the third-person tutorial series. So, when this was not even labeled as the Action RPG tutorial, we had covered this sort of aiming down sights, this fine aim, this precision aim. But it did not work as well as it should. Let me explain why the old system did not work properly. So we had a camera behind our character, and what we're doing is offsetting it to be closer to the character's shoulder as opposed to in the center. Okay, so like this is in the center of the character. But when I zoom in, you can see it's a little bit offset, so it's kind of over the character's shoulder. This is intentional. Now, before we had that effect, but if we were to rotate the character, then the camera would kind of be offset and at the wrong spot. This is because if you look at a character that rotates in place, okay? So this character, let's say, I don't even know which one's positive and negative without looking in the engine. I mean, you can see it right here. Okay, but let's say the horizontal axis is the y-axis in this case. And let's say to the left is negative, to the right is positive. All right? Now, if we have one value, one offset for our camera, and say it's like offset of 80 because we want to send it to the right over the character's right shoulder, like we have here. Well, that's great. But let's turn the character around. Let's rotate them. Well, to the left of the character now is actually the positive Y value, not the negative. And thus, the right of the character now is the negative Y value, not the positive. So they flipped because the character's orientation flipped. Well, that 80 degrees on the Y that the camera was before is now on the left side of the character. So it was causing some weird view when you were in your fine aim section here, because the actual spot in the world did not change, but the player's orientation changed. And you might be thinking, well, can't we just determine what side we're on and change the value? You could. However, the problem with that is there are a bunch of different values. So if I'm facing this way, you can see that now I'm looking in the way of the horizontal axis. So if I'm moving in that direction, it's going to get closer to the character or farther away if I'm facing this way. And it's a lot of it's a lot going on that doesn't need to be that complicated. You probably could get it looking pretty nice using that method, but I'm just going to show you a better method today than what we did in that episode. And this is going to allow us to do everything. Like I said, we're going to be able to pick up a weapon, equip it, and we'll actually be able to go up to our opponent and attack them, just like you would expect. So this can make it look really nice for this sort of combat, and this can be used for lock-on as well. With all that said, we're ready to get started. So before we do, if you'd like to get caught up in the series, we are on episode 37 of the third-person and action RPG tutorial series. So if you want to check out everything we've done to this point, I'll link you to this playlist right here. You can get caught up to every mechanic we've done, everything we've added to our game, so you can see how it all works and start working on your game. Alternatively, if you just want to get caught up in how we did our fine aim in the past, so you know what we're working off of, what we're going to change, and what we're going to have today, you can just check out this episode right here where we initially set up the logic. A lot of it is still good. There's only two major things that we have to change, and then we're going to be adding a bunch of stuff. Okay, with that said, let's get started. So the majority of the work is going to be done in code today. In fact, everything is going to be done in code today. However, I will show you some examples in blueprints and things like that. So let's start with the code. and let's go to our third-person tutorial character.h. So this is my base character. Whatever your base character.h is, we're going to do that logic in here. And let's look at something first. Before we go adding stuff, let's look at something that we have in the code from the third-person tutorial series specifically. So when we made the series, the first episode of the series, we used the third-person tutorial template, or the third-person template. And in this template, they make a camera boom and a follow camera. Now, it's not too important that you know what the camera boom does here, but I'm going to explain it anyway. So the camera boom is position. It takes the character and essentially draws a line to attach the camera to it. So the camera can follow wherever, just like in real life. Like if you have a boom for a microphone, you can move it around, you can attach it to things. That way you can have the same effect that you want with that microphone without being super close to them, right? You can get some extended reach. And that's what the camera is. It's following the character at this designated distance. And position and rotation and all that stuff as well. So we were using the camera boom before to do things like change where the boom was at to zoom in. The problem with that is if we're doing that and we rotate the boom, then the camera could be offset. Remember what I was talking about earlier where your axes could change directions based on the character's orientation. So what the world's orientation is and what their axes are could be different from how the player's seeing it, just like in real life. If you look the other way, so if you're looking a certain way and you see east is to your left, west is to your right, you turn around, then west is to your left and east is to your right. So if we use the camera boom like we're going to run into that issue. However, we can actually do the logic based off the follow camera. The follow camera is the camera we're looking through. It's the camera that's behind the character that is basically our viewpoint. That's what we're seeing everything through. So you can think of that as like the player's camera. This existed from the template. I did not create this, but we can use it today and make a lot of cool stuff happen. So if we scroll down here, we have booleans for is zoomed in, and this is something that already existed unless you're just joining us now. Which case, just add this boolean is zoomed in. And what this is if we're currently zoomed in to our weapon or our view in general. So right here in this comment, I said determines that the character is currently zoomed into their weapon. We don't have a weapon here specifically that we have to use, but it could work this way. I'm just going to actually take this out and say determine if the character is currently zoomed in. Just like that. Doesn't really matter the other context, but that's really all it is. So we're going to need this boolean today. We already made it, but if you don't have it, then go ahead and add it. Otherwise, I'm just reminding you what that's used for. It's just a boolean to toggle on and off if we're zoomed in or if we're back on the default. Okay? Now, we're going to be adding 2 new variables as well. So we need a zoom speed of the camera to get a nice flow effect so that we're going from one spot to the other. When we were doing this, you could probably see when I zoom in, it's not immediate, right? It is a slow zoom. You can make it faster than this. You could make it instant, no problem. You could make it even slower. It is up to you. I do want it to be a little, I don't want it to be instant. I think it looks better without that snapping, but you can set it up however you want. Just make sure that you have a variable here for the rate of that. The camera zoom rate is what I'm calling it. I did give it the specific U property of edit anywhere, blueprint read write, in the category of camera, but that's up to you if you want to do that. We're not going to be using it in blueprint at all today, so if you want to change it, feel free. Okay, and then I have another variable here, and this is an F vector of zoomed camera location. This one's not required, okay, but what this is this is the location of the camera while zooming in or aiming down sights. And what I mean by that is the camera has to have a location that it's trying to go to, alright? So like I said, see how it goes like kind of up and over the character's shoulder compared to where it starts? That's the location I'm talking about. Sure, we could just zoom into the character. Like I could just zoom in and be directly behind the character's back, but then the character's going to be taking up almost the entire view. So you kind of want to go over their shoulder or even over their head a little bit. You don't really want to put it directly in the center of their back. So I'd recommend having a specific location in mind that you can move the camera to, as opposed to just zooming it in and out. Again, that is up to you, so feel free to put whatever values in here that you want. But those are the two things that we need to add today. I'm going to go to the third-person tutorial character.cpp. I'm going to go to the constructor, which is where we set all of our default values. And I'm going to take a look at our two new variables and set them in here. So my camera zoom rate I chose as 0.15. And you can choose whatever value you want. It's really going to be from 0 to 1. This is a value that I chose by testing it and decided I liked it. So, you know, it's not really based off of anything. I just put in different values between 0 and 1. Found out towards 0 is going to be slower. Toward 1 is going to be faster. So 0.15 is on the slower side, and I like that, so I chose that value. Then I have zoomed camera location, and I'm setting it equal to a new F vector of values 150 for the X, 50 for the Y, 50 for the Z. And this is the position that the camera should be moving to when we're zooming in. That way we get that new view. So in this case, and probably the case of all your characters, unless you intentionally changed it, the X is going to be the depth. So it's going to be how close you are to the character. So a higher value, a positive value, this is all in relative space. Relative space is referring to where the objects are in relation to the root component. So if I look at my blueprint character, actually, I go to my viewport. Okay, so this camera, for example, this is the follow camera. The follow camera has a location of 0, 0, 0. Well, this is the relative location, okay? In the world, it could be whatever. Like this character right here, he's got a location of negative 990, 220, and 226. Well, if I look at the character in the game, actually, let's look at the mesh instead. So here we go. If I look at the mesh, well, I have 0, negative 10, negative 100. These are the relative locations. These are the locations in the world, okay? We care about the relative locations here because we don't care where the camera is in the world. We just want it to be relative to where our character is. And so these values, positive X value here is going to move the camera closer to the character. Okay, it's going to move the camera this way, closer to the character. So you're closer to their back. All right, I'm going to reset that. I have everything at 0, 0, 0. Now, the Y value, positive is going to move it to the right, negative is going to move it to the left. I want the camera to be more over the right shoulder of the character when we move it up, okay? So I'm doing positive 50 to move it 50 units to the right. So I moved it 150 units forward. And then lastly, we have the Z. Positive Z is going to move it up. So we're moving it 50 units up. That's where the camera actually exists now when we're aiming down the sights, or when we're using that fine aim. This is what it looks like. If we did this all the time, you'd see it looks like this. Okay? I could still zoom out and stuff, but that's where it would start, like that. So I'm going to send these back to 0, but just so you know what's going on there. We're moving the values on this follow camera here to be closer to this character. That's really what we're doing. So make sure you set default values for both of these variables, and then we can scroll down. A few things we want to do. So one very quick thing we should do is that if we're sprinting, I decided it should kick us out of that fine aim view. And so to do that, it's very simple. When we go to sprint in the sprint function and we set is sprinting to true, I just set is zoomed in to be false. I actually do it before I set is sprinting to be true, just so that I know the camera starts going back to normal before we start sprinting. Okay, that's a quick little addition there. And then we're going to change up our zoom in and stop zoom, or zoom in, zoom out, start zoom, stop zoom, whatever you called them. But we set up two functions in the past for zooming in and zooming out. So when we're trying to go into our fine aim and exit our fine aim. Okay, so what we were doing is we were getting our third-person camera. That's what I called it, but really it was the camera boom. It actually wasn't the follow camera. So this was kind of poor on my part back when I made that episode. I called it the wrong thing, really. This would be the camera boom. So we were getting the camera boom, and then we were changing the target arm length and the target offset. Now, the target arm length was pretty much fine, because changing the target arm length is changing the camera boom's length. You can see the red line here. So as this gets shorter, the camera is going to be pulled closer to the character. Alright, so that was a fine idea for how to do zoom. But the problem is, like I said, doing the logic off that means as we rotate the character, we could have some issues with where our camera is positioned because we were handling that through an offset. And if we do that through an offset, you will not be in the right spot. You will not be at a consistent spot as you rotate around your character. So what I've done is I've commented out these two lines. The target arm length being set to 150, which was a default value that I assigned it, and F vector of another default offset that I assigned it. I commented them out so you can see them, but you can actually delete them now. We're not going to be using them today. On top of that, if we delete that, we have no use for this third-person camera if check. So we can actually get rid of the if as well, because we don't use the third-person camera anymore in this function. I'm going to also format this how it should look. There we go. Now, this is how our function looks. We're not quite done yet. There's something else we should do in here. So we have our log, and then I've added this in here. This was not in here before. So I'm setting a boolean that is actually part of the character, not one we created. It comes with the character class, and it is called B use controller rotation yaw. The B stands for boolean. This is a standard naming convention in some cases where the type of the variable is defined by the letter in the front. So boolean use controller rotation yaw. All right, so let's take a look at our game, and I'll show you what that does. When I move my character around, I have the character currently rotating toward the object that I am pointing toward. So if I'm pointing toward that back wall and I'm moving forward, then the character is going to be looking forward. If I'm looking backward toward the camera and I start walking, then the player rotates toward the camera. And same with the left and the right. So right, left, you can see that the character rotates toward where they're moving. If I do my find aim and I move, I actually stay looking the direction that I'm looking. This is because I'm not having the character rotate at this point. The character is actually just looking where they were, and instead they're walking in the direction that I'm pointing to. So it is not automatically rotating with the direction the character is moving. This is going to be particularly helpful for locking onto enemies. Because say we lock onto this enemy, as we walk around them, the character should stay focused on them like this. Okay, so that's what that boolean does. And just so you're aware, really what that is on the, I believe it's on the character itself, might be the capsule component. But if you go to your character BP, you can search up use, and you'll see on the pawn, use controller rotation pitch, use controller rotation yaw, use controller rotation roll. So as the controller gives this pawn inputs, then the mesh can rotate toward it. Okay? And really that's what we're saying is when we're zoomed in, we do want to rotate toward the controller rotation. Because we want to be rotating toward where we are looking, not where we are moving. Because we can walk backward but still be looking at our opponent, at our enemy. Now this was something that was already in here from before. I'm actually just decreasing the character's movement. It's a default value I've given it of 300. You can make this whatever you want. You should probably assign it to a variable. That way you can manage it more easily. But this is just to slow the character down while they're walking in that fine aim view. They don't walk as fast as when they're outside of it. Then I set is zoomed in to be true. Now you'll notice something here. We haven't done anything with like zooming in. That's kind of weird, isn't it? We're going to handle this in tick because we're going to make that nice smooth transition from one position to the next on that camera. So don't worry. But we need to make sure we set our is zoomed in to true here, because if we don't do that, we won't be able to know that we're supposed to be zooming in when we get to the tick function. Now stop zoom is something else that we have to address here. So it's actually pretty similar. We were using the target arm length and setting it back to the default value. We were also resetting the target offset. But since we're no longer using either of these, I commented them out, and you can now go ahead and get rid of them. Again, because of that, we don't need this third-person camera equaling the camera boom, so we can get rid of this entire if statement and clean that up. Now, this is what we have. For this one, the only change that you have to make is setting the BU's controller rotation yaw back to false, because we want to give the character the ability to rotate and face the direction they're moving. Alright, we're no longer in that locked on state where we have to be looking at our enemy, looking at that object of interest. We're going to rotate freely again. So what we set to true, we set back to false. And same deal here. We're resetting the character max walk speed to 600, which happens to be the default value. And then we were setting a zoomed in to be false. With that done, we can go into the rest of our logic for today, which is that nice smooth effect that's going to get us from one spot to the other. This is actually going to be handled in tick today, like I said. So we had all of this in tick already. It's actually not important for today, so if you don't have it, ignore it. If you do have it, then I just went right under it. They should be completely separate. So, all I'm doing in tick is if we're zoomed in, we have to figure out where we want to move the camera to, and we're going to lerp to it instead of just setting the location to it. This gives it that nice blend effect as opposed to just forcing it to that other location and watching the snap. Okay, so if we are zoomed in, if this boolean is true, what I do is I make a vector that we can then set the relative location of the camera to. Alright, so our f vector next location, this new variable we're making, is equal to fmath : lerp. Now, this is just calling the lerp function. We need to pass an a, b, and a ratio. So, like I said, this is where we're at, this is where we're going, this is the rate at which we're getting there. Okay, so it's like driving a car, literally. A to B, you know, where we started, our destination, and how fast we were going. Okay, and so our starting location is the standard position of the follow camera. Wherever we are currently at, that's our starting position. Now, where we're going is our destination, and so we're going to use our zoomed camera location. When we're zooming in, we know that our destination is wherever this zoomed camera location is. Then the rate we're giving it is the camera zoom rate. That's how fast we want it to zoom in. Now, we need to make sure that we actually set this location. This is just making a variable and saying this is the next location that we need to go to. So, the follow camera can go ahead and have its relative location set to that new location. So literally, follow camera is a variable that I was showing you in the header file. I didn't make this. This is just the standard one on the character. Follow camera, set relative location, and then go to the next location variable. Else, if we're not zoomed in, we're zoomed out, or we're just at the default state. So else, we also can make a next location. It's really the same variable. We're just going to change the destination. So say we're zooming out, okay? We still need to start where the camera is. We don't want it to jump around. So wherever the camera is now, that's our starting location. Where we want to end up is the default value for the standard view of the character. Now, the standard view of the character is all zeros, as you saw. It is all zeros for the relative location. So it's very, very simple. But you could also, you know, if you add other locations here, just make sure you either keep track of it in a variable or you can hard code these values. Make sure it matches wherever your camera was by default. That's the destination because we're trying to get back there. I still use the same zoom rate, although you could change them if you wanted to have a zoom in be faster than the zoom out or vice versa. Then just do the same action. We're going to follow camera, set location, next location. Now, it is worth noting that this is being done in tick, which is actually fine, but you will have this called on either of these if statements, depending on if you're zoomed in or not. And so if you're already at the value, this is still going to call and go through. It's not going to change anything. It's not going to hurt anything visually, but you are going to be using this in tick. It's going to be constantly running. Don't worry, the computer can absolutely handle it. However, if you would like to cap it, you could do something like You could check and see if let's see, if the source was equal to the destination. So if we got the relative location and it was equal to the zoomed camera location already, exclamation mark to say not. So if we're zoomed in and we're not already at the spot we want to be, do this logic. You could do that if you want. It doesn't hurt anything to do this. It is an extra check that has to be checked every time, but it does stop it from trying to move the camera every time. So you can play around with it for performance reasons if you want, but it's really not a big deal, I promise. I just want to make you aware you are allowed to do that. And, you know, if that makes you feel better, go for it. If you don't care either way, just wait and see if there's anything that comes up with it. But you're good to go. I'm actually going to take it out because I'm fine with it running all the time. We're going to be doing more with the view of the camera. Things like the lock on are going to change how this works. This is going to stay the same. But when we lock on, we're going to have additional logic that we have to add to determine what to point to. So, you know, it can change a lot, and there's a lot more that's going to go in here. So I'm not worried about it right now. But guys, that's all we got. So hopefully you like this, because this is a lot better fine aim or aim down sights method for the third person tutorial series. It's not all janky now. We can move around as much as we want, and it forces our character to be looking in the way that we aim. So it gives it this more cinematic feeling. I hope you enjoyed, and I hope this helped you learn about the aiming down sights, about moving the camera around on the character, getting that fine aim, this sort of behavior, and how it could be used for lock-on in the near future. If you want to do anything to support me, please subscribe. It does more for the series than anything else you can do, and I just really appreciate it. It benefits me greatly, and it's completely free. I want to give a huge, massive shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys for everything you have done and for all the support you have shown me. It really, really helps me, and I'm just so incredibly grateful and excited to work on these series every single week. I'm glad you guys are excited to watch them and learn from them as well. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. I'd be happy to assist you and get you sorted so you can keep working on your game. Otherwise, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.